Welcome! Open your lab to problem number 20 to solve the limit analytically / algebraically. In this type of problem, we need to first substitute the x with the limit that it shows here to see what it equals to. In this problem, when we substitute the x, it equals to 0 over 0. When the answer is 0 over 0, you can either factor, rationalize, cancel, or substitute. In this case, we're going to rationalize by the conjugate. Now we're going to multiply by the numerator. Remember to change the sign. When you have two square roots multiplying, the square root cancels. Negative 2 and positive 2 cancel, and also the x on the numerator and the x on the denominator, they also cancel, leaving us with 1 over 3 times square root of x plus 2 plus square root of 2. And finally, we use distributive property. Now that we have everything factored out, we're going to substitute the x with the 0, which it finally gives us, and 3 square root of 2 plus 3 square root of 2 gives us 1 over 6 square root of 2. But remember, we can never have a square root on the denominator, so we're going to multiply the denominator on both numerator and denominator. This gives us 6 square root of 2 over 72. Then we're going to simplify. 72 divided by 6, it's equal to 12. So it finally gives us square root of 2 over 72. So our final answer is limit of x approaching 0 is square root of 2 over 12.
We're going to recap what Mariana did. So we have our problem x approaching 0. So we substituted the 0 on the problem, which gives us 0 over 0. And when we have this, we can either factor, rationalize, cancel, or substitute. In this case, we're going to rationalize. So we write our problem here. And since we have to rationalize, we're going to multiply by the conjugate. Remember to always put the opposite sign of what you have. So when we multiply square roots, they cancel. So it gives us x plus 2 minus 2. So when we multiply this, it gives us this. And negative 2 and positive 2 cancels. Then on the bottom, we have 3x, parentheses, square root of x plus 2 plus square root of 2. And the x's cancel. So we are left with 1 over 3, parentheses, square root of x plus 2 plus square root of 2. And now we're going to do distributive property, which then gives us 3 square root of x plus 2 plus 3 square root of 2. Now then, we're going to substitute the 0 from the limit in the x's, which then gives us 3 square root of 0 plus 2 plus 3 square root of 2, well, 1 over this, and it gives us 1 over 3 square root of 2 plus 3 square root of 2, which then gives us 1 over 6 square root of 2, but since we can have a square root on the denominator, we're going to multiply by the conjugate. So we write it on top and bottom, on the numerator and denominator, and then we multiply, which then this gives us 6 square root of 2 over 72. So then when we simplify, we get square root of 2 over 12. And here we write our answer, which is limit x approaching 0 equals square root of 2 over 12. So we're going to write it here. And this is our final answer. Open your lab and go to problem 98, where we're going to solve the derivatives by using definition. So remember the formula. We have it here. Don't forget. So we're going to use the formula to place x in here. So don't forget to write your notation so that we can start. So we have x squared. What we're going to do is write what's inside here, x plus h, and since we just have the x squared, we're going to write the power over here. And then we're going to use the same part of the formula to substitute this next x. So we will have 10x plus h. And then this part of the formula represents the whole problem. So we're going to write it. So now we're going to solve the next part of the equation. We will multiply by the power, which gives us x squared plus 2xh plus h squared. In this part, we have negative 10x minus 10h. And here we're going to multiply the sign by these numbers. So we have negative x squared plus 10x over h. So then we're going to look for the same ones and be canceling the numbers. So x squared minus x squared cancels. Negative 10x with positive 10x cancels. So we are left with 2xh plus h squared minus 10h over h. And what we're going to do is get that common number outside so that we can then cancel. So we're going to get the h out because in every single one of them there's an h. So we're left with 2x plus h minus 10 over x. So then we're left with this problem, which the h's will cancel. So our final answer will be y equals 2x plus h minus 10. Remember to write the little comma after the y so that we know it's a derivative. So finally, so we can have our final answer, we will substitute the h with 0 with what we got. So our final answer will be y equals 2x. We have 0 in h, so this is 0. So we get this.
So now we're going to recap the problem of derivatives solved by definition. Remember to always write the formula of the derivatives, since the problem structure needs to be based by the structure of the formula. So in every x that you find in your problem, you need to substitute by the f times x plus h. So we first substitute the x squared with the x plus h, and always remember that the power you have here, you write it outside the parentheses. Then negative 10 times the x plus h. And finally, to have the final part of the numerator in the structure of the formula, which is negative fx, which is equal to your formula, to your problem here. So is negative times x squared minus 10x, and everything is over h. In the first part of the numerator, we're going to square the first, double the middle times 2, and square the last. So in here is x squared plus 2xh plus h squared. Okay? On the final problems of the numerator, we're going to use distributive property, which leaves us with 10x minus 10h minus x squared plus 10x. And finally, we're going to cancel out all the numbers that are the same, but with a different power. So the x squared minus x squared, the negative 10x plus the 10x, which leaves us with 2xh plus h squared minus 10h over h. Now we're going to isolate the common variable, which is h. So we leave h out of the parentheses, which gives us 2x plus h minus 10 over h. And finally, we cancel out the h's to finally have y apostrophe equals 2x plus h minus 10. And finally, we substitute the h with the 0 to finally have y apostrophe equals 2x minus 10.